Okay, so the last little bit we'll look at is something on missing values. So you would have seen when we plotted the penguins data that we had some missing values there. And you can see that when we compute the mean flipper length here, which is just a mean function, then we get NA. Okay, so we need to add NA.remove equals true to fix this. Let's just put that there so we can see what happens. Then we get the right answer, right? 200.9. So that's removed the missing values first and then computed the mean. Okay. So this is where the missing values are explicit. They're actually listed in the data frame. Okay. But another way missing values can turn up is when they're implicitly missing, and that is when rows are missing completely from the data frame. And that happens in the roll data. We've got no NAs at all, but we do have missing data still because there are rows that are missing. Okay. So for example, if we wanted to find the average number of students in each gender across schools, we could try this code here, which would work just fine and give us an answer because there are no NAs in the data, so there's nothing to mess up the mean computation. We don't have to put NA.remove equals true or anything like that. It gives us an answer that on average across the schools there are 163 females and 170 odd males, but this answer is actually wrong. And the reason for that is that there are no entries in this data set where the number of students in a category is 0, yet of course we know that some students will have no students of a particular ethnicity, gender and level combination. For example, single gender schools, right? So in Palmerston North we've got Palmerston North Girls High and Palmerston North Boys High. Presumably there are no boys at Palmerston North Girls High and similarly no girls at Palmerston North Girls High School. Okay. So we would expect some categories in there to have the number of students of that category equal to 0. Yet we have no rows in our data. I've just tried to find rows where the students is 0. There are none of them. Okay, so those rows are implicitly missing. Okay, they're just not there at all. So clearly our computation of the mean is going to be wrong here, because you remember the mean, we add up the number of students, so we count the students that we have. That won't be affected by the zeros, because of course the zeros won't count. But then we divide by the number of rows, the number of observations. And the zeros, of course, are valid observations, but they're not being included. So our means that we've computed are going to be higher than they should be, because we're not including the zeros in the data set. Okay, so for example, let's just have a look at some schools. So we're going to pull out the schools with grammar in the name using str_detect. So we're grouping by gender and school, and we're summarizing the number of students. So this is the number of students by each gender. And we're looking at the grammar schools. Then you can see that at Auckland Girls Grammar, we have 943 female students, but of course we have no male students. Similarly at Auckland Grammar, we have 2,606 male students, but no females. There's no row for females. Okay, there are rows for females and males at Mount Albert Grammar, because that is a dual-sex school. Same with Mount Roskill Grammar and Takapuna Grammar and I think Cathedral Grammar. But these Auckland Girls Grammar and Auckland Grammar are single-sex schools. So we know we should have another row in the data set for each of these with a 0 in the number of students. And because we don't, the means are going to be wrong. Okay. So one way to fix that is the complete function. Essentially, what this does is it adds all of the other possible combinations of the data back in. Okay, so here we're going to grab our data like we have above, number of, we're grouping by gender and school and summarising the number of students, and then we're ungrouping to just remove the grouping thing. So now we've got gender, female and male, and then we've got school. But we know we're going to have some missing rows in here. For example, we're not going to have a row female Auckland Grammar. We're not going to have a row male Auckland Girls Grammar, right? And so the complete function essentially gives us all of the combinations of gender and school, even the ones that we don't have. So it just gives us all possible combinations of the things that we tell it to give us all possible combinations of. Right, so we're completing the gender and school. So here, notice I've got 4,934. After I do the complete, I've got 5,066. So I've added some extra rows. To look at where they might be, we could have a look back at the grammar school, and you can see here that I've added the corresponding rows for males in Auckland Girls Grammar and for females in Auckland Grammar. And of course, we don't know the answer to the number of students, or at least the computer doesn't know the answer to the number of students, because it's just added additional rows and it doesn't know what to fill in for those other entries. We know, of course, that the value should be 0, right? So we can fill in those extra values. Okay, so let's take our data. Right, and when we complete the gender and schools, we're going to use the fill parameter. So I seem to remember, let's have a look at the help for complete, figure out how to do that. It's a list, I think, isn't it? A named list for each variable supplies a single value to use instead of NA for the missing combination. So let's have a look at the help here. So you can see that they've done fill list value 1 is 0. So they're trying to fill in the value 1 column here. So we're going to try and fill in the students column with 0. Okay, there we go. So that's one way to do it. Let's check by grabbing out the Auckland Grammar stuff. Then you can see I've replaced them with zeros. The other way to do that, so that's one way to do it. The other way to do it would be to do the complete as per normal, and then do replace NA. So replace NA. So replace is a list of values again, and you just specify which columns you want and what you want to fill them in with. So that will do the same thing. Okay, so those are the two ways to do that. With the NA values replaced, recompute the mean number of male and female students across all schools. So this is the last thing we have to do. So let's grab maybe with this one. Right, and so we want to do the mean number of students. So summarize mean is going to be the, we're going to have to group back by school and gender. No, we want to group by just gender, isn't it? And we want to do the mean number of students. Okay, so you can see here that the answer is now 160 and 166, which is lower than the answer that we got right at the start, which was 163 and 171. Okay, and the reason that it's that this answer was incorrect is that we were missing those rows. So the denominator, when you compute the mean, was not including those additional rows. Therefore, when you do the division by the denominator, you get a larger value than you should have got. Okay, so it's just something to watch, that sometimes, particularly if there's things like no zeros in your data, it might, and they count, it might be suggesting that they just haven't been included. Okay, that's it. I'm going to finish by knitting the document, which will of course run all of the code from top to bottom, and we'll interweave the writing, the narrative, the code, and the output charts and all that sort of stuff into a single big long workbook that I can then look back to later.